Welcome. Today, we are looking at gas laws. This is topic 9 in your SS1 physics series. This topic often appears in essay questions in your examinations. Pay close attention. Let us begin. First, let me explain what gas laws are. Gas laws are the laws that describe the behavior of gases. They describe the relationship between pressure, volume, and temperature of a gas. Gases are unique. They have no fixed shape or volume. They expand to fill their container. They are compressible. They exert pressure on their container. Understanding gas laws is essential for understanding the behavior of gases. It is essential for understanding thermodynamics. It is essential for many applications. Examples include engines, refrigeration, and scuba diving. Gas laws are fundamental to physics and chemistry. Now let me explain the properties of gases. Gases have several properties. First, they have no fixed shape. They take the shape of their container. Second, they have no fixed volume. They expand to fill their container. Third, they are compressible. They can be compressed into a smaller volume. Fourth, they exert pressure. The particles collide with the walls of the container. Fifth, they have low density. The particles are far apart. Sixth, they diffuse. They spread out to fill their container. These properties are explained by the kinetic theory of gases. The kinetic theory states that gas particles are in constant random motion. They collide with each other and with the walls of the container. These collisions produce pressure. Understanding the properties of gases is essential for understanding gas laws. Now, let me explain the kinetic theory of gases. The kinetic theory of gases explains the behavior of gases. It has several assumptions. First, gas particles are in constant random motion. Second, the volume of gas particles is negligible. Third, the forces between gas particles are negligible. Fourth, collisions between gas particles are elastic. This means no energy is lost. Fifth, the average kinetic energy of gas particles is proportional to temperature. The higher the temperature, the higher the kinetic energy. These assumptions explain the behavior of gases. They explain pressure, volume, and temperature relationships. Understanding the kinetic theory is essential for understanding gas laws. Now let me explain Boyle's law. Boyle's law describes the relationship between pressure and volume of a gas at constant temperature. It states that the pressure of a gas is inversely proportional to its volume. When volume increases, pressure decreases. When volume decreases, pressure increases. The formula for Boyle's law is P1 times V1 equals P2 times V2. P1 is the initial pressure. V1 is the initial volume. P2 is the final pressure. V2 is the final volume. Boyle's law applies at constant temperature. It applies to ideal gases. Boyle's law is important in many applications. It is used in pumps, syringes, and scuba diving. Understanding Boyle's law is essential for understanding the behavior of gases. Now, let me explain Charles's law. Charles's law describes the relationship between volume and temperature of a gas at constant pressure. It states that the volume of a gas is directly proportional to its temperature. When temperature increases, volume increases. When temperature decreases, volume decreases. The formula for Charles's law is V1 over T1 equals V2 over T2. V1 is the initial volume. T1 is the initial temperature. V2 is the final volume. T2 is the final temperature. The temperature must be in Kelvin. Charles's law applies at constant pressure. It applies to ideal gases. Charles's law is important in many applications. It is used in hot air balloons, thermometers, and engines. Understanding Charles's law is essential for understanding the behavior of gases. Now, let me explain the pressure law. The pressure law describes the relationship between pressure and temperature of a gas at constant volume. It states that the pressure of a gas is directly proportional to its temperature. When temperature increases, pressure increases. When temperature decreases, pressure decreases. The formula for the pressure law is P1 over T1 equals P2 over T2. P1 is the initial pressure. T1 is the initial temperature. P2 is the final pressure. T2 is the final temperature. The temperature must be in Kelvin. The pressure law applies at constant volume. It applies to ideal gases. The pressure law is important in many applications. It is used in pressure cookers, car tires, and engines. Understanding the pressure law is essential for understanding the behavior of gases. Now let me explain the general gas equation. The general gas equation combines Boyle's law, Charles's law, and the pressure law. It is also called the ideal gas equation. The formula is P times V equals N times R times T. P is pressure, V is volume, N is the number of moles, R is the universal gas constant, T is temperature in Kelvin. The ideal gas equation applies to ideal gases. It is a good approximation for real gases. The ideal gas equation is important in many applications. It is used in engineering, chemistry, and physics. Understanding the ideal gas equation is essential for understanding the behavior of gases. Now, let me explain the concept of an ideal gas. An ideal gas is a theoretical gas. It obeys the gas laws perfectly. The particles have no volume. There are no forces between particles. Collisions are perfectly elastic. Real gases do not behave perfectly. They deviate from ideal behavior. However, many gases behave nearly ideally under normal conditions. The ideal gas equation is a good approximation. Understanding the concept of an ideal gas is essential for understanding gas laws. Now let me explain the concept of absolute zero. Absolute zero is the lowest possible temperature. At absolute zero, particles have minimum kinetic energy. The temperature is 0 Kelvin. This is equal to negative 273 degrees Celsius. Absolute zero is the point at which volume and pressure would be zero. This is according to Charles's law and the pressure law. However, absolute zero cannot be reached. It is a theoretical limit. Understanding absolute zero is essential for understanding temperature scales. Now let me explain the applications of gas laws. Gas laws have many applications. In scuba diving, Boyle's law is important. As a diver descends, pressure increases, volume decreases. The diver must equalize pressure. In hot air balloons, Charles's law is important. As air is heated, volume increases. The balloon rises. In refrigerators, gas laws are important. Gases are compressed and expanded. This absorbs heat. In engines, gas laws are important. Gases are heated and expanded. This produces work. In weather, gas laws are important. Changes in pressure and temperature affect weather. Understanding gas laws is essential for many fields. Now let me explain the differences between the gas laws. Boyle's law relates pressure and volume at constant temperature. Charles's law relates volume and temperature at constant pressure. The pressure law relates pressure and temperature at constant volume. The general gas equation combines all three. Each law describes a different relationship. Understanding the differences is essential for solving problems. You must know which law to use for each situation. Now, let me explain how to solve gas law problems. To solve gas law problems, follow these steps. First, identify the known quantities. Second, identify the unknown quantity. Third, choose the appropriate law. Fourth, substitute the values and solve. Fifth, check your answer. For Boyle's law, use P1 times V1 equals P2 times V2. For Charles's law, use V1 over T1 equals V2 over T2. For the pressure law, use P1 over T1 equals P2 over T2. Make sure temperature is in Kelvin. Understanding how to solve gas law problems is essential. Now, let me give you sample exam questions. State Boyle's law. Boyle's law states that the pressure of a gas is inversely proportional to its volume at constant temperature. State Charles's law. Charles's law states that the volume of a gas is directly proportional to its temperature at constant pressure. State the pressure law. The pressure law states that the pressure of a gas is directly proportional to its temperature at constant volume. State the general gas equation. P times V equals N times R times T. Explain the kinetic theory of gases. Gas particles are in constant random motion. Collisions are elastic. Average kinetic energy is proportional to temperature. Define absolute zero. Absolute zero is the lowest possible temperature. It is 0 Kelvin or negative 273 degrees Celsius. Let me summarize. Gas laws describe the behavior of gases. Boyle's law relates pressure and volume at constant temperature. Charles's law relates volume and temperature at constant pressure. The pressure law relates pressure and temperature at constant volume. The general gas equation is P times V equals N times R times T. The kinetic theory of gases explains the behavior of gases. Absolute zero is the lowest possible temperature. Gas laws have many applications. Understanding gas laws is essential for physics and chemistry. Practice these concepts. When you have them down, move to topic 10.